Hi guys, today we're going to do a few tests on my Mac Pro, classic Mac Pro 5.1, and we're going to look at the different speeds of USB and the different types of USB 2, 3, 3.2, Gen 2, FireWire, which is an old connection for the Mac Pro, and the SATA, which of course is the internal interface, and NVMe. So we talk a little bit. Some things are quite basic. If you don't want to go through the whole process, you can just jump at the end, and you will see, the final results of everything. But it can be instructional or anyway interesting for some people. So yes, let's start going and look. So hard disk drives, these are mechanical drives which are running at different speeds. At the end of the day, it's a bit like a turntable. It's like you have an LP, and the difference is the head is reading from the small to the outer circle, from the inner to the outer circle. It's goes very fast because anyways it's 5,400 RPS revolution per second, so that's really a lot. So the reader, the laser head, has to go back and forth and look for the spaces and stuff. So I have with me three different types. I have both the 5,400, the 7,200, and 10,000 revolution per second. So let's give a look at the difference in these things. And SSDs, they are different in the sense they save the data on a chip, so it's much faster. We will see. And one thing about SSDs is say that they are kind of limited in time, and this means that every time you write something on a sector, which is bytes, of course, this is like there is like a countdown. Still, things are not very clear because SSDs are quite new in the history of technology, and in this sense, we don't know exactly how long it's going to last. Probably, anyway, we're talking about a few years. So if you have a decent backup system, you can just don't worry about this. Okay, interfaces. Okay, we have the different interfaces. We have the internal SATA, USB, which in the Mac Pro is limited to 2.0, the FireWire, which was a faster interface for the time. The very first was 400 megabits per second, which would be 40, more or less 40 megabyte per second, and then the second version was 800. The classic Mac Pros, the very early ones, the 1,1 and 2,1 have FireWire 400, and the later models, the 4.1 and 5.1 and so on, they have the 800. Then we have the PCIe interface, which is to which you can attach different devices, and among other things, and NVMe solid-state storage media, which is very fast. And then we have Thunderbolt, which is again an Apple system, and you can use it again to attach a different peripheral, and that should be very fast. I don't have a Thunderbolt card or a Thunderbolt hard drive, so this will not be part of this test. Test software. The Mac test software quite sucks. Fortunately, before we were just using the Blackmagic Disk Speed Test, which is okay. It's fancy. It has a bit of animation and things. The little meters go up and down and stuff. But the point is that before there was clear disk, crystal disk for the PCs, and now fortunately they made a Mac version which is called Amorphous Disk Mark, which is much better, and this is the one we use. Also because it will give you different readings. They will give you the sequential reading, just like Blackmagic Disk Test. Now the point is that sequential reading is just continuous reading or writing on a hard disk, which is quite uncommon. We have to look at the situation. This is, how the inside of your disk looks. There is here, for example, there is a big chunk of very long sequential writing. This was a video file which was written when the hard drive was completely empty. And then here we have lots of different files. So what happens is that when your hard drive is reading things, very seldom it's going to read or write sequentially all the file along. It's going to most probably jump around from different things and looking for files and chunk of fragmented files or applications. So in this sense, this will logically slow down a lot the work of the machine. SATA speeds. Okay, let's start from the internal things. Here we have the 5400, 7200, 10,000, and then I also added an SSD. So logically you can see quite clearly the 5400 sucks, poor thing. I mean, it's doing 65, 66, read and 53 megabyte per second. Jumping on a 7200, already we have a better performance. The performance on a 10,000 is bigger and is proportional, to the amount of revolution per second. It's a bit better. It's difficult. They are difficult to find, this kind of disk nowadays, and at the end of the day, I don't think that it's really worth it, but it was interesting to have it in and just look at it, how it works. I don't have an external 10,000 hard drive, so in this sense we are not going to use that for the other tests. It was just here to have an idea. Logically, you can see the jump on the SSD we are having compared to old-fashioned 5400, which unfortunately still you can find in many external portable hard drives. So you can see the jump is from 66 to 288 megabytes per second. I mean, logically it's much faster and is over the double of a 17200 external drive. Now, SB, which one should we use? It's quite of a mess because there are these different standards, the 2, the 3, 3.1, 3.2, 4, and even the things are quite strangely connected. Now, one very good thing, especially, I mean, if you're using a classic Mac Pro, something that you should never overlook is the definitive classic Mac Pro upgrade guide by Greg Gans. Now, this is a fantastic upgrade guide, and he has also great YouTube channel, and which you can choose and see, and has a lot of information. Now, regarding the mess in the USB naming convention, he made also an interesting video, and that's what about the Mac Pro and using NVMe USB-C card and so on. So that you can see. From that video, I just took a little part. Let's listen to it.
Now I'm going to get into why we're talking about this, because it is absolutely bonkers insane when you start talking about the USB naming conventions. It's like someone at the USB consortium is out there to get us all and mess with our heads. In 2013, USB 3.1 was released, and thus USB 3.0 needed to be renamed. It became USB 3.1 Gen 1. Then in 2019, when USB 3.2 was finally released, we had to do the renaming shuffle again. USB 3.1 Gen 1 became USB 3.2 Gen 1. And then anything that was USB 3.1 Gen 2 became USB 3.2 Gen 2. And then the latest and greatest, which was originally going to be called USB 3.2, became USB 3.2 Gen 2 X2. This is also not touching on the USB 4 standard, which is essentially the convergence of Thunderbolt 3 plus USB 3.2. But what the hell do I know? I'm only a UX developer with a concentration in accessibility, so yeah.
Yeah, it's funny, isn't it? Anyway, so we have maximum transfer rates in theory. So you can see one important thing, on the Classic Mac Pro you're limited to USB 2 and FireWire 800 as a standard connection. Then unless you get a PCIe expansion card with USB 3.2 Gen 2 or NVMe or Thunderbolt and so on. Anyway, so you can see the USB 2 it had a maximum transfer rate of about 60 megabytes. FireWire came up with 80. Now we saw before that already having the hard drive on the SATA thing, you will get a faster connection. USB 3, 625, 1250, 200, and so on. Thunderbolt should give you up to 5 gigabytes per second, which is quite outstanding. And again, unfortunately, I don't have a Thunderbolt card, so we cannot really see the real thing in practice. USB 2 speeds. Now, so we will just check the three drive I have, which is a 5400, 7200, and SSD. Now, yes, things getting even sadder. 5400 will give you about 29 megabyte reads and 25 write. 7139, and SSD will give you 40 or 33 on write. I mean, these numbers, they do change, sometimes are a bit irregular. Anyway, these are very, very good things. So we can see USB 2 speeds are dreadful, and if you use it, it's just a pain in the neck. FireWire 800, we can compare it to the USB 2 speeds. You can see you have about 83, 76 speeds, and you know, just it's nothing still compared to 28, 39, and so on. One interesting thing, though, in this tests, and you have to see also, is the fact that these are the numbers for random reading on different depth, and this is the same to two different depths. Now, actually, you can see, for example, a FireWire will have 5245. You have 63, 62, 36. The randoms are very, very different from the sequential reading. And again, this is something to consider, because most of the time your computer will work on random speeds. So the flashy big numbers we will see are still quite interesting. Anyway, let's give it a look again. So this was the FireWire. The FireWire, I tried to put as an SSD, but I couldn't dismantle because my FireWire external hard drive was the encrypted disk, so it cannot be just swapped easily, and I didn't want to be bothered doing other things. So I got an Allegro Pro PCIe card. This is quite good. It's not the very, very best. It's good because it has two controllers. One control the first two ports and the other one is two ports. So in this sense, it's not sharing one bandwidth with all four ports. At least you can attach two USB devices at using integrated full potential of the card. So with this, we have to look at a bit of enclosures. So I have an USB 3 enclosure in which I can change the hard disk inside. I just bought newly USB 3.2 Gen 2, which is supposed to be much faster. And this, just for comparison, is an external Samsung T7 drive, which they advertise as is able to do 1000 megabytes per second. So let's see how this will work. USB 3 speeds. We can see we still look at a big difference with the random values. So anyway, on USB 3 you have 36, 115, 458 for an SSD, and the T7, which is in fact faster, gets to 459. Random's value are pretty good on the SSDs compared to the ridiculous amounts on hard drives. Now we use the 3.2. I don't have a 3.1, so we just jump from 3 to 3.2, and we can see things go a bit better. Still, anyway, the 5400 and 7200, they have reached their limits of speed, more or less, and so that's what you get. It's not that different from before. And things are getting better on the SSD, in which you can see you have 565 and 755 for the T2. Undoubtedly, the T2 is faster, but at the same time, if you really see the difference between the random reader writes of the T7 from a normal cheaper SSD are not that great. So at the end of the day, we will see, is what should we do with this? NVMe speeds. So we got also an NVMe PCI card, and so you have an old standard for Apple, which is AHCI and NVMe. I got a very cheap Wolftech, which is a very good card with an AHCI card, so we can compare the two. Again, the differences are not huge. I mean, we're talking about a much better result. You can see here, I mean, we have 1600 here, close to 1700, and this is really the top what you can get on a PCI with one card. So this is, very good. This is what you get, more or less. This is what you can get on a Mac Pro. Again, the read and write are much better. This is fantastic in the sense, and in here you really see the difference, I think. To have even higher speeds, you should have a PCIe card which is 16 lanes with 4 NVMe drives, which you will put on a RAID, so combining the 4 as one big one. At that point you can get 6,000 megabytes or more, which is definitely something. It's still quite an expensive solution, but I mean, the speed's supposed to be amazing. Final results. Okay, if you didn't fall asleep yet, so now we can just jump and look at the graph with everything. And this is on my Mac Pro. This means, hopefully are okay reads. The speeds should be all right, and but it depends probably on machines. Sometimes the tests and the kind of hard drives you use. I just use some quite standard hard drives and SSDs, and I don't want to name any companies because anyway I don't make any money. So let's look at it. Ba-bam. All right. Well, nothing new here. So you can see logically the fastest is the PCIe card with either an HDD or NVMe card. Drive. Now the difference is so relative that if you find a cheap AHCI card storage device, if you get it for free or cheap or whatever, maybe easy is more convenient. You can pay much less than an NVMe. So anyway, logically these are the things. What else we can see here? As we were seeing before, the USB 2s logically have the slowest speed. The FireWire is in the middle, and the SATA is interesting in the sense this is an SSD on SATA. Logically, it's much faster than what you have. What else you can have at that point? And the thing is, many people, especially for example, people using Logic and audio DAW programs for recording audio and editing audio, they have the plugins and sample loops and stuff on a SATA disk with SSD. Actually, you can see that if you connect that on a USB 3, it will, or even better on USB 3.2, is going to be much faster. So maybe you can consider, if you're working strongly with audio, would like to have a better solution, instead of plugging into the SATA port, plug your SSD on a USB 3.2 Gen 2 and you will get, or just a USB 0.3, and you will get a much better result. So yes, this is, logically the T7 is the strongest among the external hard drives as we saw it, and again, I mean, it's a good difference but nothing special. So this was that, and thank you for watching. If you want to subscribe, I seldom put up things, but anyway, I hope it can be helpful. Give a look at my other videos, and anyway, put like if you like it on the below link. I have all the links for Greg Grants, and again, don't hesitate. I mean, just go and look at this stuff and read this definitive Mac Pro upgrade definitive guide, because it's really well done. Thank you very much. Cheers. Thank you for watching.